Hello everyone. Today we discuss analog and digital converters. Basically, it comes under data converters. What are different types of ADCs and what is ADC and what are different types of ADCs? Are the contents, and we'll see specifically a flash type ADC. ADC stands for analog to digital converter, where basically naturally available signals are analog and we have digital signal processors. The analog signal has to be converted to digital, so we'll be using analog to digital converters. Here we see today about the conversion process and all. So basically available signals are analog, where it is represented with x of t, which are continuous. Such signals has to be interfaced to a digital system. So analog signal is there and digital system is present. So an interface which converts the analog signal into digital signal is needed. That is the analog to digital converter. Here there are some examples. Voltmeter. This is a representation of analog and this is digital. Next, voice signal. It process the voice will be analog. This process digital signals. These are two examples. The conversion of analog signal to digital signal involves 3 steps. First step is sampling, second step is quantification or quantization, third step is coding. These operations are all performed in the same element A to D converter. That indicates that all these functions are done by the analog to digital converter. Conversion process, first step is the sampling. This is a sampler. The digital system works with discrete states. The signal is only defined at determined times, and we can obtain that particular signal by using this sampler. When see this diagram, this is the analog signal and you are sampling this one. See the green lines, these are the sampled signals that we obtain from a sampler. Now that digitized signals, here we have the digitized signals, and these can be represented or taken for quantification. Quantification in the sense we'll be assigning some possible levels for that particular amplitude levels. Some standard values we are going to assign by using this quantification or quantization process. So here are the levels represented with q between these t between these two intervals t, and this quantization here we represent it as q, and we are going to assign this particular level to this. Like all the signals will be quantified. After quantifying, they become discrete signals. Then conversion process will start. Now we start assigning the values for that particular levels, amplitude levels. Similarly, as in the previous slide, here also we will be assigning by taking this into account, matching the digital signal. So this signal will be matched to this signal will be matched to this, like that all the signals we are going to take and we are going to represent. Example, take this is represented with 0, this level is represented with 1, this represented with 2. Next, the accuracy of the analog to digital can be improved by increasing the sampling rate and resolution. So here you can have a signal which is having high sampler rate and high resolution. Sampling rate in the sense in here, and high resolution means here. So Nyquist-Shannon theorem tell about the sampling frequency. Next, sampling rate. So you have to suitably choose the sampling rate and go for analog to digital signal. Here we connect a analog filter. So the example gives you a 8-bit converter, and the range of conversion will be 5 volts and the sampling time will be 1 milliseconds. So here you can have an example. Next, different types of ADCs. The different types of ADCs are flash type ADC, sigma delta ADC, dual slope ADC, successive approximation ADC. Now we'll discuss parallel type or flash type ADC. So here, to convert an analog signal into digital signal, we need 8 operational amplifiers. Operational amplifiers in the sense, here we are using the operational amplifiers as the comparators. Here they are arranged in this fashion, where we are having the resistances, voltage divider network with 8 resistors, and the comparators, operational amplifiers, 8 number we are going to use, and each comparator will have one threshold level here. That is, one end of the comparator is connected to the V reference and the voltage divider network, and one more terminal is connected to the Vn, that is positive term. For all the positive terminals we will be connecting Vn, for all the negative terminals we will be connecting the reference voltages. When reference voltage is applied, some standard value of voltages as per the values of resistance will exist at each and every comparators inverting terminal. That is, due to the voltage divider network, V reference voltage, different voltages exist at all the inverting terminals of the operational amplifier. When Vin is applied, where Vin is the external voltage what we apply, for conversion. This is the analog signal what we want to convert into digital. When this signal is applied to all these comparators, basing upon the potential present at the inverting terminal, the comparators will start changing the states. Here we know that the comparator will change its state from plus Vsat and minus Vsat only. So here they will change the state in that particular fashion. So after changing that states, you will find different values at the input of this priority encoder. That is, previously all the states are said to be equal to 0, and when Vn is applied, only few states, possibly basing upon the value of the input voltage, one comparator may be on, 2, or like that. You can have 8 comparators can be made to on conditions, or combination of all these, or few of these may be on and few of these may be off. Now different values of inputs will be applied to the priority encoder. This priority encoder will encode these inputs to 3-bit binary output. 3-bit binary output, and this binary output is treated as the equivalent value for the given input signal Vin for this flash type ADC. So here this is the action of a comparator. When Vin greater than V reference, the output will be high, and Vin less than V reference, the output will be low. So this is the conditions for the comparator. So if you see the advantages of a flash type ADC, first advantage is it is very fast than all other techniques, and disadvantages also we have. We need 8 number of comparators it has low resolution, it is expensive, and it consumes large power. This is about flash type ADC. Thank you.